Welcome to the ARISTEiA podcast, where experts talk about excellence, academic and industry insights. In today's podcast, we're honored to have Dionisios G. Vlachos, Unidel Dan Reich Chair in Energy, Professor of Chemical and Biomolecular Engineering, Director, Catalysis Center for Energy Innovation, CCEI, Director, Delaware Energy Institute, DEI, at the University of Delaware in US. And Irini Angelidaki, Professor, Department of Chemical and Biochemical Engineering, Head of the Bioconversion Section at Technical University of Denmark.
My name is Irini Angelidaki, and I'm professor at the Technical University of Denmark at the Department of Chemical and Biochemical Engineering. I have wide expertise in bioconversions of biomass to bioproducts, biofuels, bioenergy production, in optimization of anaerobic processes and development of sustainable solutions for organic waste, for wastewater treatments. I've been member of several international biotechnological environmental journals, and I have also served in several national and international committees and worked in a range of organizations and research bodies. I have coordinated and participated in a large number both of Danish research projects, but also EU research projects, national and EU funding. And I'm also I'm holding an ERC advanced grant as well. So I'm leading the Bioconversion Center at the university, which is at the Department, as I said, of Chemical and Biochemical Engineering, which is actually this Bioconversion Center is an active and dynamic research group working in the areas of biogas, biofuels, microbial electrochemistry, microalgae, biorefineries, and everything that has to do with conversion of wastewaters to products in a bioeconomy approach. So, Dion, you can also present yourself.
Thank you, Irini. I'm Dion Vlachos. I'm a faculty member at the University of Delaware in the United States. I'm in chemical and biomolecular engineering since 2000. I was before that at the University of Massachusetts in Amherst for 7 years, and I got my PhD from the University of Minnesota in undergraduate education from NTUA, from Athens. I started actually as a modeler, so in the 90s we were developing multi-scale simulations, capabilities, algorithms, mathematics. But the last 15 years, I transitioned my research program more into the sustainability and circular economy. We were fortunate to actually start a center on biomass conversion that Irini was speaking about. This was all primarily on thermocatalytic conversion, so we use catalysis and energy to convert things like wood chips and other waste streams, food waste, into valuable chemicals and fuels. So this actually center I was directing lasted for 15 years, 3 cycles of Department of Energy. I'm currently part of the Plastics Innovation Center, which focuses on plastics recycling. So we take some of the knowledge we learned from converting biomass into complex solid feedstocks, plastics. In parallel, my group actually has started a few years ago an effort on electrification. That is the possibility of actually supplying green electricity to drive endothermic reactions, which are very heavily very high temperature, very, very high energy load, with the idea of actually decarbonizing the chemical industry. I'm also directing the Energy Institute at the University of Delaware. There's an umbrella organization that brings together people across the campus with biology, with techno-economic life cycle assessment, background, chemical, mechanical engineers, policy, and economics. And tell us a little bit about your thoughts about circular economy, waste utilization. How do you see the energy transition? And in particular, what is the role of the European Union in this? How much support is there? What's kind of the vision of the European Union?
Thank you very much, Dion. Very interesting questions you put up. In order to reduce our dependency on fossil natural resources, basically we need to rethink. Bioeconomy is, in my opinion, an economy that relies on renewable resources, natural resources, to produce food, energy, and fuels. So it strives to reduce our dependencies on fossil natural resources, for the first, prevent biodiversity loss, for the second, and also create an economic growth in line with the principles of sustainable development. And here we should remember that we have the term of circular or cascade-based bioeconomy. So what do we mean by that? We mean that we need to use natural inputs, expend minimum amount of energy, and do not produce waste. So this is actually, we understand that all materials discarded from one process are inputs for another process, and they are reused in the natural system. The heart of the circular economy is the principle of waste minimization. This involves reducing waste at the source, redesigning products for lasting as long as possible, and promoting reuse and recycling. This is the circularity of what we're talking. The objective is to create a closed-loop system where materials remain in use as long as possible and do not create waste. Of course, I would say it's not possible maybe to come with zero waste, but this is our target. So this applies to several sectors like manufacturing, construction, food production, which actually are sectors that they are increasingly adopting circular economy principles to cut emissions and reduce resource depletion. So these are all hanging together with sustainability, where we need to keep the capital while using the profit of these processes. So this is the bioeconomy, or the circular economy, where we reuse, we create zero waste. And this is a very important, essential part in the green transition. Transition means changing. So we need to change to the green thinking. So the green transition refers to a systemic shift towards sustainable and carbon neutral economies. It involves clean energy adoption, decarbonization, and sustainable practices. So these are the two concepts we're talking about. So green transition is a complete transformation of our thinking and the way we are. And the part of it is actually the circular economy. In the EU, we have the Green Deal, it's called. And this serves as a guiding framework for this transition, for this green transition, which we integrate circular economy principles in key sectors. So of course, this has also to be quantitative. So in EU, in the Green Deal, we set ambitious targets, like for instance, achieving carbon neutrality by year 2050. And that means actually complete carbon neutrality, which does not only requires that we cut down on our emissions, but we have also to pull out some emissions away. So the carbon storage as well, because that's not enough just to cut down in emissions. We have to capture also CO2. So that's actually what the EU is doing. But of course, I would not say that everything is perfect here. We have, despite significant progress to the circular economy, we still have challenges, like, for instance, the regulative framework in Europe is extremely strict. And as also von der Leyen, the commissioner in Europe, has said some weeks ago, that, and also it's very well acknowledged, that that Europe is actually regulating, while, for instance, China is copying and the United States are innovating and Europe is regulating. So we'll actually pose the same question to you, Dion, about what is the situation in these aspects, also concerning United States, what is going on. Although we know, of course, that you have new policy, new government now, but share your thoughts to us of how it's actually this green transition and circular economy is working in the United States.
Thank you, Irini. Thank you for the comprehensive answer. the question and sharing all the thoughts. I starting from the end of your discussion, I have the impression that the EU is ahead of all other continents in terms of regulation, and quite ahead by several years in comparison, for example, to the US. I have also, the thought that in the US, when they invest in money, we invest in serious money, we can invent. We have a lot of creative minds, so we can move things fast. And this is something that, it's not the US and the EU are going to solve this problem. It's a global world, problem, the whole energy sustainability problem. And we need to bring, all the continents and all the countries together. But then, the most developed, countries, economically stronger countries are the ones who should lead, this transition. The circular economy is just, one pillar. It's not, enough to ensure, a sustainable, future. And just to explain to people why is that the case, that I think there are two aspects here. One, when we take, a plastic and we try to turn it, back into plastic again, new plastic, or a textile, right? We try to recycle, back. We have maybe an efficiency at best about 90%. So that means that only 90% of the carbon we're able to capture, back. So if you do the multiplication, 90 times 90 times 9, 80%, 80 times 80, 64%, in a few cycles, all the carbon is basically lost. So if we want to really avoid the use of fossil fuels and get into a sustainable situation, we need to start to think about the renewable sources that Irini talked about, basically, biomass and other waste, streams that have to come in. And this carbon is basically captured from carbon dioxide in the atmosphere through photosynthesis. It grows into trees, the plants, and then we use those. So renewable carbon is extremely important. In the US, we also have put the last few years a lot of emphasis on waste utilization. Plastics is probably the hottest topic today, but all the waste streams are important. Something which a little bit, in my view, not as much emphasized, especially in the US, is the food waste. I have seen much more emphasis in EU in terms of food waste. And this is critical because a huge amount of biogas, methane, and CO2 are released to the atmosphere from the digestion in the landfills and contributing to greenhouse emissions. So looking at some of these waste streams is critical in the US, should also take another leadership role. So the second aspect, one has to do with the carbon loss. The second aspect has to do with the manufacturing. Whenever, as a chemical engineer, we do something in the processing, we use energy. And that emits carbon dioxide. And so if we do the whole circular economy in a traditional manner, as we call it, business as usual, that would imply we basically are going to convert solid, feedstock, let's say plastics from the landfill, into carbon dioxide in the atmosphere. And that's not a very brilliant engineering. We need to figure out how to do that in a sustainable manner. So using electrons that it can come, from solar, from wind, or whatever other sources different countries have, because they are very distributed energy sources, becomes, very important to be able to drive, these highly energy demanding processes. This can be the steel, the cement industry, and the chemical industry. These are the three major industrial sectors. We're taking a lot of emphasis on, electrification of the transportation. That's another important piece because it has been one of the major energy polluting sectors. We know about the Teslas, but a lot of American now companies as well as European companies are leading the way of electrification of the transportation sector. That's harder actually to do for the aviation sector, the sector in terms of the fuels, because either hydrogen or batteries are not, really don't have, the density that you need for this transportation. So there are still a lot of open questions. The US in the last few years has taken a lot of action especially through the federal funding, but also the industry has been responding quite positively, realizing these challenges that are global. Most of the companies, US companies, are actually global companies, as the European companies are. And so they need to take a global view, and irrespective of the local policies in time, what happens, for example, in Washington, what happens in Brussels, we have to be thinking more globally, long term. And in that respect, the US industry is looking more long term, irrespective of the particular government, because they know the government changes every 4 years. But what is going to happen long term and the ability to operate in different continents and countries is going to depend on them taking a more global view to the energy transition. Right. So that's kind of summarized just some additional thoughts to what Irini said that in an excellent way. Maybe, Irini, to continue this conversation, in terms of your own personal research, what do you see that have been some of the critical directions that you need to take and maybe your subfield should take in order to address, this energy transition and some of the environmental challenges? And you can bring also a couple of examples, so our people can understand. That would be great.
Actually, as I mentioned before, my research is developing technologies based on the power of microorganisms, so biological conversion processes. So we convert different wastes, as you also mentioned in your research, to useful products, biochemicals, biofuels, even food. So I want actually first to stress out that microbial technologies constitute a huge and unique potential for confronting major humanitarian biosphere challenges. So these technologies evolve rapidly. We have powerful approaches. I mean, if you see that in the world we have like 1 trillion microorganisms, and you look in the pangenome of these microorganisms, we have a huge possibility to do everything actually, which actually can be powerful approaches for novel products, novel processes. When we understand the metabolism and this pangenomic power which the microorganisms can have, we can really do anything. So we can help restore environmental health, we can improve soil fertility, we can enable regenerative agriculture, we can reduce biodiversity losses, reduce pollution, and so on and so on. So at the moment, we don't really know everything, or this capacity is not deciphered yet. So at the moment, we know less than 10% of the microorganisms, and we actually have isolated even fewer than them. But nowadays, with the genomic information and the omics in general, we have the possibility to go in and really target and see the functionality of several microorganisms, what they can do. And with the automation that comes along, and the possibilities actually become endless, what we can achieve with this microbial capacity. So I would say that this has been a little bit overseen, because up to now we basically could identify the biochemical steps, but we did not really know the functionalities, that the possibility we had there. So this is just to make an introduction of the power we have in our possibilities to do. And as I said, I work mainly in a biotechnological process to convert waste. In the past, waste were seen as a nuisance and a load to the society, but now we see them as a resource. So we can convert them in different ways. And actually, I'm working in different biotechnologies where we don't focus only on precision fermentations. That means one microorganism to do that, because that's not possible when you work with this kind of material biomass, which is waste. They have toxicity, they change in composition and so on. So there actually we work in making mixed culture fermentations, but not randomly assembled mixed cultures, but cultures that they are actually knowledge-based, so we can make the metagenomic analysis. We know which actually microbes we need, and then collect them and put them together to make a knowledge based on genomic information, microbial consortia, to achieve specific biotechnological processes. And that's not only that we can do it, but also we increase the yield by decreasing the number of unwanted products. So we have more focused consortium just to make exactly what we want. And we make actually, my ERC grant is based on this kind of work to make a new actually age of biotechnology based on knowledge-based microbial consortia for mixed culture fermentations. So some examples I will say to you: we can convert biogas now to biomethane, so that will substitute the natural gas. Another is to convert actually biomass through thermochemical process like pyrolysis, and then take the syngas, and that we will convert to fuels like ethanol, hexanol. We can make acid like isocaproic acid, which is very good chemical. We can convert waste to biofuels, and even actually we can make proteins. So in the future, you can see that we don't need actually to make vegetable-based proteins, soya protein, or meat protein. We can make proteins in fermenters, gas fermentations, and then have excellent properties of proteins. And we collaborate here with some other universities, Copenhagen University, for instance, where they functionalize this protein. So they basically extract it, lysis the cell, extract the protein, and then functionalize it to make, for instance, milk, ice cream, yogurt. So all this actually will be in the future the new milk we drink. So we will have milk without a cow. And I would say also a provocative question to you, Dion, would be how can you see what will be the fueling of our cars in 2040 or 2050 from now? And how will we heat our houses in the future? So can you somehow share some of your thoughts about that for the future of our societies?
Yeah, thank you, Irini, for the very exciting answer that you had about, how biological methods, approaches, technologies can actually, help us with the energy transition. I think, the goal is by 2050 to decarbonize all the major, sectors. I think this is a very globally, this is a very tall goal. Some studies I have looked at, they project, and projections are typically, wrong, that by 2050, we're going to have still 50% of the cars on the road would be electric, and other 50% would be actually fossil fuel. So one of the realizations is we depend so much on fossil fuels because the cost is very low, and the infrastructure is so well established that it's very difficult for us to actually detach from the fossil fuel world. Yet we need to develop thermocatalytic technologies, biological technologies. We need to enhance the production of solar and wind that we have seen much more, about 10% increase over the last, or 10% of the energy now makeup is coming more or less from renewables. I remember when I was a student, that was just a couple of percent besides the nuclear. So we have seen significant increase in the renewable energy, and I think this is a sector that needs to be developed. We have another challenge which has to do with the grid. At the moment, all the grid is using energy either from natural gas or from coal or from renewable sources, but the grid is not large enough to be able to handle the whole energy sector. And so we need to modernize and expand our grid. We need to expand also the energy storage because the renewable energy is intermittent. And so we need to be able to put it somewhere in cases we don't have enough wind or enough solar, let's say in the Mediterranean countries. So we should be able to store the energy and be able to move it around with the grid. There's no question that I think globally, especially the US and EU, are set to move towards the energy transition. We're going to see significant changes by 2050. But whether we will be there, my personal opinion is we will not be able to get there. But unless and control the temperature globally to 1.5 degrees, but unless we take action now, or even yesterday, we will not be able to get closer to the goals that they have been set for 2050. Irini, I have another kind of question. We live in different continents. You guys are more. You have multiple countries, but then we have also multiple continents across the world. In your opinion, how much synergy is needed between countries within EU, but also between continents? How much real coordination is needed to be able to realize the energy transition, the sustainability?
Yeah, actually, this is something that worries me because all throughout my life I have been living in peace age. But now it seems actually that the world is getting more polarized. And this is actually worrying me because I think that we researchers, that we make the innovations, should not think politically and really collaborate with each other and be open-minded, because I can see this polarization actually also somehow hinders our integration with each other and the communication with each other, and this should actually not happen. I think we should be open-minded with the whole world, including China, and all researchers will be for the gain of the world and not necessarily that we should look very narrow-minded about a specific political situation and country that we support. And I would like to add something on what you said in respect to the renewable energies like windmills, photovoltaics, and biomass energy. And here, actually, my point of view is that electricity and heat, electricity specifically, we can put attention on windmills and electricity and photovoltaics, while we can keep biomass for these gaps, to fill the gaps. For instance, biomass is not an endless resource, so therefore we cannot entirely substitute fossil resource with biomass. Therefore, we should make more intelligent and appropriate use of biomass resources. We can get much more value of biomass. And as you said, also, we have to fill the gap. So when the wind is not blowing, then we can actually somehow store the energy in the form of, let's say, methane. We can make electricity, electrolyze water, make hydrogen, and then that hydrogen we can use to do some, for instance, make methane or make other products. So I think we have to distinguish, use the electricity where we can immediately, while the biomass can fill the gaps and make more high-value products. So this is, I completely agree with your view. This is the distribution we should have in the future. But in respect to collaboration, I think we have to be very, very careful, because I know that also European countries, and I guess American countries also, start actually also putting this polarization also to researchers and to university levels. And I personally protest against that in order to move to the climate, actually to solve the climate change challenges, we really need to work together all over the world.
Let me ask you another important aspect. Research is critical to advance the technologies, but we need also to develop the next generation of people, right? Our students. To what extent in Denmark and European Union you have seen changes in the education? And what's your views in terms of what we need to do to meet, to really train professionals in industry, but also, at the graduate students or even high schoolers, to really prepare them, for the energy transition?
Yeah, I completely agree with you in that point. To facilitate the green transition, higher education, both in Denmark and in EU and the whole world, needs to adopt a strong sustainability in strategy. And I would be very glad to say that my university, the Technical University of Denmark, has sustainability in the strategy as a strategic point. So all students should have sustainability course, life cycle assessment courses, and so on. And besides that, sustainability has been to be embedded. The university has embedded sustainability principles in all disciplines, from engineering to business and humanities. So we learn actually how the principles of sustainability. So the courses should focus on interconnected challenges, so think holistically, including energy, climate policies, circular economy, and biodiversity. And I would say in this sense that actually Europe is really very much focusing on that. I was last week, actually, just came Friday back. I was in Germany, where actually I was involved in evaluation of Helmholtz Institution. And there they have also very strong, actually, the sustainability and also the social aspect as well implemented in their research. So not only the technical development, but also the social aspect, not only the sustainability, but also the social aspect, how that influences the well-being of humans and how the perception is done that in all different aspects. So this multi-faceted approach is really something that we look very much into in Europe. And also I would say, in order to achieve this sustainability and green transition, we need technical training, expanding programs in renewable energy technologies, sustainable architecture, green engineering. So teaching students how to design waste-free regenerative production systems, green entrepreneurship, which actually will support startups and innovation in climate tech and green business models, mission-oriented research. So there are many, many initiatives, and I would be very proud to say that this multifaceted approach and sustainability, focus on sustainability, is really driving very much education in Europe. At least in Denmark, we have a lot of attention on that.
Thank you, Irini. That was great. I agree with you. I think the future is our young generation, and we need to train them. We need to retrain professionals in the current industry so they know how to handle whether it's hydrogen economy, hydrogen hubs, and fuel cells, and biotechnologies. We need to figure out how to do this. There's a lot of effort in the US the last several years on training students across the board from what we call K-12, from kindergarten all the way to graduate students and postdocs, and even train ourselves right into this, because it's a completely emerging new field. At the same time, I think we're not where we need to be. I think we need to invest more in education and programs. It's not necessarily that trivial to integrate sustainability in the whole undergraduate curriculum, especially in the US. We have a fixed number of courses, credits the students can take. But we have been having an energy, for example, concentration or minor for undergraduate students who are between different departments in engineering. They can take this and learn a lot about sustainability aspects. You mentioned something else which I think I want to re-emphasize about the policy, the social components, right? The breadth of the energy space is huge. We need to actually train people to understand, what is the ramifications of political decisions, what's the role of policy, what's the perception of people, because they don't want to have a wind turbine in the backyard, right? The wind turbines may kill some birds, and so there is a lot of social push from people who don't understand fully the ramifications. So educating also the social, the general public, I think is also very important. So they don't throw things at the beaches, a plastic bottle. And so education across the board, I think, is very important. We need to be working again together between the continents to share, best practices and experiences and how we can do that. We can all benefit from this. I have one kind of last question, maybe, Irini, if I may ask. What's your favorite, kind of person, scientist, engineer, that you would like to go out, for dinner with, and what place would you pick to have, a discussion with this person?
I have not thought really about that. I can see the question that you asked me now, but well, maybe, what can I say? If I could invite somebody that would have an impact, maybe I would invite your president to explain him the need for, I don't know, for the green transition and how important it is. So I hope that I can convince him over dinner, cozy dinner.
Okay. If you don't mind, I will join you too, so we can try together, right? Join forces.
Yeah, I didn't think of this answer, but I mean, this could be a good chance actually to explain your president what we're doing and the need for.
All the politicians. Maybe we should have a good discussion.
Yes.
Bring some of the scientists and try to use layman terms to explain to them the impact.
We can explain in a pedagogic way what we mean and what we are doing actually. So maybe people can appreciate and see the need for that.
So I think, Irini, this is bring us to the end, right? Of the podcast. Thank you so much, for participating. It was fun to see you. Great talking with you.
Thank you very much, also Dion, for the pleasant conversation. And we shared our opinions of what is going on around the world and the needs for this green transition and the needs of the technological innovation, actually, which is a prerequisite to succeed in the green transition. And I will also thank very much ARISTEiA podcasts for giving us the opportunities to be here in this podcast and talk a little about our thoughts around these topics. So thank you very much, both Dion and ARISTEiA, for this opportunity. And thank you,
Irini, and ARISTEiA too. Thank you.
A huge thank you to Professor Dionisios G. Vlachos and Professor Irini Angelidaki for this podcast, ARISTEiA in 30 minutes, where experts talk about excellence.